Hello guys, hello world, hello Philippines, hello. So I'm gonna show you another example problem solving of reaction kinetics problem number 2. Okay. Okay. So we have the problem. The data table below shows the concentration of reactant with respect to time from zero order reaction. What is the value of the rate constant? K. Oh, rate constant for zero order. Okay. Okay. So problem number 2. The data table below show the concentration of reactant with respect to time for a zero order reaction. What is the value of the rate constant? This is our problem. We will get a table like this. So this is A. So the unit will be M. Molality, then you have the time from the seconds. So for results, like 7200.5600 0 5 15 40. So this one. Okay. The data table below show the concentration of reactant with respect to time for a zero order reaction. What is the value of the rate constant K? So we are asked for the K, rate constant K, and our order of reaction is zero. So we have the formula of K for the zero order reaction, right? K, in which R is equals to K, directly. Okay. So we have the molarity M for the concentration, moles per liter means 0.800, 0.7200, 0.5600, and 0.160. So with corresponding time starting from 0, 5, 15, 40 seconds. Okay. Since the molarity M, capital M, and the seconds are given, so our unit will be MS for the rate constant. Rate constant is our solution, is the one asked for the problems. K is equals to the rate constant unknown, and your unit will be M over S. This is the unit because, okay, we have the M, we have the S. Okay, like that. So this is the K. So of course, this unit is zero order reaction. And aside from that, it's mentioned in the problem, this is really a zero order reaction because the N is equals to 0. In a zero order reaction, here, there's no chemicals mentioned in the problem. So we need to have, the hypothetical equation or chemical reaction, which is A to B. Sorry, zero order reaction A to B, like that. A to B. Okay. Or let's say A to B or A to B, like that. So A to B na lang siya. Reactant A will produce product B, or it could be A to B. Most of the times in the books are A to B. B is the product, but let's just put B as our product. First letter of the product, okay? Like that, capital B. So our concentration, here A. Our focus is here, right? So we need to say the rate law of A decreases and the rate law of B increases. The rate of reaction of A increases and the rate of reaction B increases. Okay. Then concentration of A, okay, is higher at the initial stage and it will become less during the chemical reaction. Okay, so initial concentration is higher, and then when it will undergo chemical reaction, the initial concentration. Okay, so final minus initial. Okay, like that. Okay, if the concentration is high, and it will become low somewhere in the chemical reaction, right? Correct. Okay, this is big, and then it will go the reaction, it will become less. So like that. Okay, so negative dA, the rate. Okay, this is the rate low, or the R. Okay, the R. This is the rate low, or RA, or the R is equals to delta change of concentration A over the time. This is the rate involves time. Okay, so this will be negative because it will decrease. Okay, when it will go a chemical reaction, meaning it slower down. Okay, the rate of reaction. Okay, like that. And your initial concentration of the product will become less. Okay, starting from big here, like that. Okay, big here meaning big here, and then the concentration will decrease going to B. So reverse, the concentration of A will become less in the product. Okay, and the negative B decrease also the rate of the chemical reaction. Directly proportional. Okay, the rate of reaction will decrease. Okay, like that. So our formula for K for the zero order, we have already that one. So again, so K is equals to, okay, AO over 2, okay, A, okay, raised to the power O, okay, R, K, A, O. Ganon. Raised to the power 0, so anything 1. So R is equals to K lang siya. Okay, R is equals to K. I will show you this is very dirty. Okay, too much paper kasi. Okay, kaya parang parang naguguluhan ako sa paper. Hindi ako naguguluhan sa problems, but naguguluhan ako sa paper. It will add confusion. But, okay, so ito na lang siya. Sana mo ito? Sana may whiteboard ako para it's very easy to discuss with having a whiteboard, right? Like this. So we have first order reaction N is equal to 0. Zero order N is equals to 0. Okay. R is equals to Ka raised to the power 0. R is equals to K times 1. R is equals to K. Okay. This is zero order reaction. Okay. This one. N is the order reaction of zero order. Okay, so R is equal to K times concentration of A raised to the power zero because N is equal to zero. Anything raised to the power zero is always equal to 1. So therefore, the rate constant is just equal to the rate law. Okay, for the zero order, meaning it is not dependent with the initial concentration or the concentration of the reactants. It's dependent because in the equation, it does not involve the quantity concentration. Okay, like that. Now we look at the table. Okay, like that. Since R is equal to K naman siya. Okay. Oh my gosh. This one. Okay, table. So R is equals to K. So we have 0.800 in the first. Okay, 0.000 in the first. And we have the time is 0. Okay, like that. So you look at the table here. Okay, it's decreasing, right? And the time is increasing, right? So like that. So you need to know that this is a zero order reaction. Okay, so we have this formula. A F is equals to negative A times T plus A O. Okay, like that. So, but our concentration is no longer needed here. So, cancel is equals to 1. Then negative A is equals to, okay, 1 over T. Like this. Computing for the K, another way around in the integral rate. This is integral rate law, and this one is the rate law standard. Okay, integral rate law standard. Since A cancel, so this will remain. So here the negative K, and here it's positive K. Okay, the rate law. They are not equal actually. Okay, like that. So solve for the value of the rate constant. Okay. Okay. For the first 0.8 molarity, so our time is 0. 1 over 0 goes to 0. Okay. This is zero order, right? And then at K is equals to 1 over T, 1 over 5. Here, 1 over 15. Here, 1 over 40. Okay. 1 over 40. Okay. Like that. Okay, this one. We use this integrated law because there's a time here in the standard rate law. R is equals to K. Okay, there's no T. There's no time, right? Like that. So here is there's a time. There's a time here. So what is the value of the rate constant? And actually, this molarity is just only a confusion. Okay, because in zero order, the concentration is not is dependent man siya, or is not dependent man siya in sa concentration. Okay, the data table below show concentration reaction with respect to zero order siya. So in zero order, dependent siya sa concentration, but in the table also for the concentration is given. So that means that it made us confused for the students also. Okay, because in the equation here, we don't incorporate the concentration in the zero order in the standard law. R is equals to K. And then in the integrated law, negative K is equals to 1 over T, and you can compute for the K, right? And all K is negative also. Okay? Let's see if it is correct K. Okay? Then we have another analysis. This is our first analysis. On the spot kaayo, no? Okay? Let's say, let's see. What's gonna happening for that, okay? Since atong pugson siya, okay, because there's a concentration, let's just try to imagine, let's forget the theory that the concentration is not dependent, okay, like that. So independent siya sa concentration based on the formula, right? But still, we need to use this data, okay? Sample lang siya, okay? Like that. So, mapugos siya o gamit sa ganun siya. Okay. Dilagi siya pwede. Di siya pwede. Katugid siya. Rate constant equals 1 over t talaga siya. Okay. There's no other thing. Okay. So, rate. Okay. K. Let's say A0. So, assuming na lang ni siya. So, let's say 0.800. So, A0, like that. And we have a K here. No, time. So, a time is equals to 0. Our concentration, okay, is from 8 to 0.7200. Okay. This one. This is initial, and this is final. This is the final, initial, and initial, final also for the time. Okay, so delta change in time. Okay, because we are dealing with a rate, delta change times time. Okay, and then the change of the concentration. Like this, pugso na to siya. Okay, ano siya ba? Delta change in A, delta change in time. Kinaman siya time, nasa siya concentration. Okay, though the theory states it is not dependent on the concentration. Let's forget that first. Okay, like that. Okay, so A is equals to ano siya? So 0.8. So like this. And then you'll multiply this 0.8, multiply this by a factor to become 0.7200, okay? So let's say, ano lang siya? X, the X, calculator. Lisod man siya, we cannot say times factor of 2, times factor of 3, because it's decimal places, see? Some textbooks are saying the rate law times 2 times 3 times 3, and what's gonna be our rate law? It's very easy because that's whole number. Okay? But here it's not whole number, see? Even you multiply to it will never result to this concentration. So let's solve na lang siya. So 0.720, oh my gosh. 0.7200 divided by 800 sa ka-0 equals to 0.9. 0.000 divided by 0.7200. So 0.7200 divided by 0.800. 0.9 talaga siya. Okay? First concentration in the trial 1 in the experiment, okay, times X, which is the factor to be multiplied so that it will be equal to the second reading, which is 0.720 concentration also, similarity. So X is equals to 0.9. This is the factor that we, so this is, okay, A times 0.9, okay, is equals to the rate, okay, like this, because this is delta change in time, okay, like that, like that, okay. So pila man siya, so 0.9 raised to the power 0, zero order man yun siya, so 0.9 raised to the power 0, so doon na rin mo siya consideration, so 0.9 raised to the power 0 is equals to the rate, pila man yung rate ani niya, so mag-multiply sa factor ani pala agi sa table, okay, this one. Okay, from 0 to 5, like this. So, 5 siya. Okay? But that is not a rate, right? So, delta change in concentration is equals to 0.9. Okay? 0.7200. Okay, divided by 5. Ganun. So, anything raised to the power 0 is 1 good siya per me. So, 1. So, 1 is equals to R. Ibalik ko ni mo siya dire. Ganon. Okay? This one. Okay? Like this. Okay? So, this is not valid also, because, you know, it doesn't meet with us here. Okay, because at first it becomes 0, and here is 1.1 here. Okay, so it's not equal, so this is not valid. Okay, so we need another try to compute for the K. Okay, so we're gonna use the first order is AO. It's equals to KT AF AO. Okay, now pugso na to siya. At this time, pugso na po na to siyang isod ani nga rate law. Okay, because the first and the second, it looks like sablay siya. Okay, so let's force this, because this is zero order reaction. Okay, so A niya, gamito na to siya ang katong kuan kani siya. Kani na po siyang gatan, ha. Dapat man siya good. Kung nag-prepare pa lang po, if I prepared how to solve this, then perfect, one try only. But I did not prepare how to solve this. Okay? That's why I keep on first try, second try. This is third try. Okay? So A. So our A final. So this is gonna be our A final. This one. 0.7200, and then it's our initial, right? Okay? So, final is 0.72, and then K times 0, initial plus 0.800. Okay, so 0, so 0.720. At time is equals to 0, okay, it's not possible, okay, because this is 0. 0 times K. 0 times K, how much? Not equal, because 0.7200 is not equal to 0.800. This is wrong, okay? This is wrong. Okay, and then second na sa siya, din na punta sa okay, din na punta sa 0.5600 our final, and then mo sa niya itong 0.800 atong initial. Okay, Fermi man siya initial kanin 0.8. Okay, take note, this 0.8 it's Fermi na siya initial, AO na siya Fermi, ha. Okay, ang final name mo, kanya siyang tulo. Okay, kaya una man yun siya. Okay, so final will be 5.6 na. So A final 0.56. So negative K. Ang time na to ani niya, ano ni siya? Okay? Kidiri naman ta siya. So 15 minus 0. So 15 siya. Kaya doon ta change in time at siya. Okay? So 15 minus 0, so 15 siya. Okay? Sorry. Plus initial. Atong initial mo na ni siya, 0.8. Okay? 0.8. Kasi pagsaon yun siya. Okay? So negative 15K is equals to 0.5600. Okay? Minus 0.800. So K is equals to 0.56800. Negative 0.24 divided by negative 0.15. 0.24 negative 0.15 is equals to 1.6. Cancel negative, so K is equals to 1.6. K is equals to 1.6 in case for this here. Okay, here. Okay, third try. This is the third try, right? Because if you use the second try, we obtain not equal man siya. Obtain 0. Okay, then last try 1.600. Okay, this is our final. 1.600 negative K times ang time niya is 40 seconds man siya. So 40 minus 0. So 40 siya. So 40 lang yapon siya. So when okay 1600 final is equals to negative K 40 negative 40 minus 0.800. So K will be equal to 0.166 minus 0.800 is equals to divided by 40. 0.1600 minus 0.800 negative. Okay. Negative siya. Then divided by 40 siya. Negative 0.016. Negative, positive siya. Positive 0.016. Ganun siya. So there are two Ks obtained, 1.6 and 0.016. This one is 1.6 times 10 to the negative 2. And this one is simply 1.6. So which of the two is correct? Okay, since you have only to show the only one. You have to choose this one, either this one or this one. Now, you have the R is equals to K, right? The rate is always equal to K. We cannot, we cannot have the relationship between K and R because it's just equal. Okay, so what can we do for this? So let's say, for the concentration, okay, here, okay, here, let's say we are using the K, okay, so it's between the two, 1.6 and 1.6 times 10 to the negative 2. But I think there is more appropriate for this. Okay, but I think it's gonna be Y because 1.17 is initial. So this is the final 0.160 minus 0.8 man siya. Okay? So final siya sa concentration minus initial sa concentration. Ang final na kumaman siya initial. Okay? Final initial. This final initial sa time. So this one is somewhere along the middle man siya. Kani siya. Individual man siya. Individual final and individual initial we solve it. This one. But this one is for the overall man siya. Final concentration minus initial. over 40 minus 0. Something like that. Okay, I think this is the correct one. K is equals to 2016. Okay? Di ba ako na itong gikuha ng answer para na-prove na ko correct ba siya? Because in this case, I'm not really sure. Okay? Again, 0.16. I have to prove wait, minus 0.8. So, okay. Ganon. Divided by 40. Oh, sakto siya. 0.0 ginawa. Okay. So, 0.1600 minus 0.800 divided by 40 minus 0. Same answer here, which is 0.016. Okay, this is correct. 1.6 times 10 to the negative 2 is the rate equation constant. Basing on this table that we have the initial and final in the overall accounting of the concentration. Not focusing on the middle, because in the middle you can also consider the final here, the initial, final here, initial, like that. Okay, but it's not logical also that this one also, okay, like that. So that's why this one is correct. We'll put that here. So like this. Rate. Kiningon lang siya good. Ang rate is equals to constant sa zero order. So ang rate is equals to K na siya automatic. So ang rate is delta change in temperature concentration over delta change in time. So 0.1600 muna siya yung tabo. 40 minus 0. Ano siya? Diba? So in the theory, the rate is equals to K directly. Since the rate is equal to delta change in concentration over delta change in time. The change in concentration is from 0.1600 final minus 0.800. So 0.1600 minus 0.800. And then for the time, 40 seconds final minus 0 initial. So 40 minus 0. If you divide that one, you can obtain a K which is also equal to the K we solved here. Okay? See? K 0.06. By using this formula, which is a zero order in an integrated law. Okay? So meaning to say, the integrated law and the original law, this is the original law without integration, is just have the same value. Okay, so shall we say this is the correct answer? Okay, because the integrated law rate constant is equal to the integrated law K na na-solve nato siya. Okay, so the answer will be rate constant is equal to 1.6 times 10 to the negative 2. Since this is a zero order, so this is M over S unit for this. M over S, unit of K, here. M over S, because this is zero order unit for K. And this is also M over S, here. Now, concentration M and siya, S sa denominator. So MS, okay, it makes sense. Okay, molarity, M put in M and siya tanan M sa the denominator is second. So second mentionary, so M over second, so equals siya. Okay. Okay, makalibog siya, di ba? Okay, but you have to, analyze the situation. Okay? Ganon. So our answer will be 1.6 times 10 to the negative 2 meters per second. Okay? Do not use the negative and negative 3 because means sometimes the exponent, if you wrong in counting the zero, then you will be wrong. Just use the, the point something, the numerical. So like it's 0.016. It's okay. If you try to change that to 1.6 times 10 to the negative 2, sometimes you count the zero, you will be wrong, especially if you're getting hairy. Okay, then the choices of the question, there's times 10 to the negative 2, times 10 to the negative 3, and you will wrong. So it's better to use the 0.016 as a figure. Okay? Then if the choices are having exponent, then count. 1, 2, 1, 2, ganun, ganun. So that we can answer that in terms of exponential form. Ganun siya. Okay? Like that. Okay? So this is, ano ba ito? Chemical Engineering Board Examination 2007. Okay? This question is BS Chemical Engineering Board Examination 2007, November. Okay? That's why it's difficult. Because November examination is very difficult compared to the May examination. Okay? Imagine if I would be in that examination, I take three trials, right? Okay, try one, try two, in one problem only. See, maybe I will be out, the time will be finished, and I'm still in the chair. Others are going out already, just because of this. And then this is not only the question. This is only number one. So there are 100 questions, 80 question like this. Oh my God. Okay, ganun siya. So in this situation, put in your mind the rate law na lang siya. Ano na lang siya ha? Okay? Put the rate law always in your mind, and then use that equation 2 to make sure that you are correct. Okay, because the other one, because here, see, what confused me also, because in the table, there's no rate. Okay? So, time only and the concentration. Normally kasi, in this kind of problem, there's a rate also given. Then, oh my God, I was shocked, there's only 2 columns. Okay? Usually there are 3 columns, 4 columns, but in here, 2 columns only. I understand that because this is zero order. Okay? So it will be minimized the number of columns because R is just equals to K. Parang ganun siya. Okay? Like that. It's not an issue really for the concentration. Think for this. It's not really an issue for the concentration, but why they put the concentration on the data here if that is not really, dependent in the concentration? Sometimes you will confuse, right? Because the theory states in zero order reaction, it is not dependent on the initial concentration or the concentration, but the problem has the table concentration already. Normally, as an average student, as an ordinary student, you will be lost, okay? Because wait, this concentration, the theory said that it's dependent, not dependent. Oh, it's dependent. Sorry. So actually, there should not be concentration given, right? Okay, so that's my first confusion. That's why I have try one, try two, and try three solutions. And the try three solutions are correct, right? Oh my gosh. Ganun siya. Ganun katindi. Okay. November examination is very difficult compared to the May. Okay. And there's always lesser who passed the examination like that. Okay. 24 like this. Out of 10, only 3 like this, okay? Ganon. Okay? Grabe siya. Okay, thank you so much. Nakutawa akong ulo for that. Akong brain cells. Nasakit akong brain cells. Charot. Okay. Thank you so much for that. Watching this video. It's a little bit of confusion. Okay. So I said to myself, if this is gonna be found difficult, and then I am a chemical engineer, how much more to the students that are not chemical engineers, right? So for me, just go to the most basic formula to be used, something like that. Okay, do not go to the difficult one because it will confuse you. Okay, unless specified to the problem, or if the problem requires for that to use those complicated formulas, but stick to the most basic formulas. Okay, just like this. I think it's difficult, but it's not difficult at all. Okay, and I was confused. Okay, thank you so much. Bye bye. God bless. Okay, ganun lang siya. That is the problem number 2. Okay.